So today we are going to discuss about DAC. Okay. So based on design thinking approach. Based on design thinking approach. So we all know very well about design thinking. Okay. What is design thinking? So it is a human-centric approach. It is a human-centric approach to solve the problem. Okay. By collecting requirements or needs from the user and generating ideas. Okay. And finally creating a model or prototype. So this is the definition of design. So what are the 5 stages of design? Can anybody answer?
There are 5 stages on the design thinking. The stages are empathy, define, ideate, prototype, and testing.
Test. Very good. So can anybody answer what is empathy?
Empathy is all about the ability to imagine and understand the user's needs.
Very good. Very good. So defining the problem statement by observing all this empathy points. So empathy can be taken from the users by observation or by interaction. Okay. So collecting all these points, we can define the problem statement. And the next stage is ideate. What is ideate?
It is the way to generate different ideas and learning concepts.
Okay. So ideate means creating multiple ideas for the particular problem statement. And the next one is prototype. So that is using these 3 stages, we can create a model, and the last stage is testing. So we can finally test the prototype or model. Okay. So these are the this is about the design. Okay. So let us move on to the topic. So today's topic is digital to analog converter. Next. So first we should know why we need DAC. Okay. So there are some applications need analog signals. So the digital signal should be converted into analog signals, and we can use in audio systems. So in audio systems, it is the DAC is used to convert digital music into analog sound for microphones. Microphones that is for speakers and headphones. Okay. And the next one is communication systems and motor speed control. So the DAC is used to control the motor speed. Okay. And instrumentation, it provides analog output for CRO, waveform generators, and measuring devices. And the last one is process control systems. That is, it converts digital controller output into analog signals for actuators and pumps. So these are the needs of areas which we need digital to analog signals. Okay. So the next one is define. So next. So define. So digital to analog converter is an electronic circuit that converts binary data into the analog signal, that is voltage and current, voltage or current. So already we know that digital is a discrete value or binary values, that is zeros and ones, and analog is a continuous in time. Okay, so this is the block diagram. So input is digital input and the output is the analog. Okay, so the main areas are audio systems, communication equipments, process control, and instrumentation, where the digital outputs from microprocessor must control speakers, motors, actuators, and valves. Okay. So next, there are some specifications for to define a DAC. Okay. So there are 5 points, and the first one is resolution. So resolution is the smallest possible change in the output should reflect in the output. So smallest change in the input should reflect in the output. That is called resolution. And the next one is linearity. That is, linearity in a digital to analog converter. It is the equal increment in the digital input should result in equal increment in the analog output. It is called linearity. That is, if we increase the input signal, it should reflect in the output also. Suppose, for example, if we increase from 0011 to 0100 in the binary, that is the input, and it should reflect in the output. For example, if the output value is for 1.1, it should change from 1.1 to 1.2. Okay. So the next one is accuracy. Accuracy means the difference between the expected output and the actual output. So the accuracy percentage is 0.2 percentage. For a 10 volt scale, it is the difference of output voltage is 20 millivolt. And the next one is settling time. Settling time means to settle the time for that is the conversion time. It is otherwise called conversion time. After applying the input voltage, how long it will take to convert the input signal. That is called settling time. And the next one is temperature sensitivity. For any input that is due to the components, that is operational amplifier, resistors and voltage sources, the input may changes for the due to the temperature sensitivity. So these are the solution. And the next one is the types of analog to that is DAC. There are two types: weighted resistor network and DAC, and R2R radar. Okay. Can anyone summarize today's class?
Networks digital to analog voltage or current source. They are widely used in process control, audio systems, and communication controls. The specifications of DSCs are resolution, linearity, accuracy, temperature sensitivity, and finally settling time. Thank you.